Hey folks, welcome to today's class on the renal system. In this class I'm going to cover the functions of our renal system, the gross A and P of the organs that make up the renal system, and the physiology of how our kidneys actually filter waste products from our blood. Alright, let's start off by discussing the function of the renal system. I'm going to focus on the kidneys. Now I think the kidneys are underappreciated. I mean, when you talk to people about kidneys, they automatically think about making pee, right? Now, that's a pretty important job, but our kidneys do much more than that. And I'm on a mission to increase your knowledge of these organs. Let's call it Love Your Kidney Month. First, yes, your kidneys do have the capacity to filter blood and remove metabolic waste. Every cell in our body has a job, and in the course of doing that job, the cells conduct chemical reactions that produce waste products. Much of this waste is in the form of nitrogen-containing chemicals. I'll show you a little more later how this waste is removed and eliminated in urine. Your kidneys are responsible for maintaining the proper amount of water in your body, and water levels are directly related to every other fluid level. If you have too little water, that will deplete your circulating blood volume. Too much, and you can actually drown in your own fluids. Your kidneys also maintain the amount of electrolytes in your body, things like sodium, potassium, chloride. Our kidneys keep track of the levels of these elements, and they can either hold on to them or release them in the urine. Electrolyte disturbances can adversely affect everything from nerve cell function to your heart's contractions. Maintaining the proper balance of alkalis and acids in our blood is also a function of the kidneys. We can tolerate only minor fluctuations in pH. When we get too far out of whack, nothing works correctly. Heart, brain, respiratory organs, etc. And then you die. Our kidneys are dependent on a constant supply of blood and actually have the ability to monitor blood pressure. So, when our BP drops, the kidneys signal the central nervous system to kick it back up. Too low, and it sends a signal to bring it down. Finally, our kidneys monitor the amount of oxygen in the blood. Oxygen is carried on red blood cells. If the oxygen level drops for any period of time, the kidneys sense this and release a hormone that actually increases red blood cell production. So as you can see, your kidneys are two of your best friends, so show them a little appreciation, okay? Now let's talk about the organs that make up the renal system, and they're pretty simple. The kidneys do all the heavy lifting. Then we have these two ureters that transport the urine produced by the kidneys to the bladder. Now we're all very aware of our bladder, especially when it starts talking to you when it gets full, right? Then there's the urethra. This is the tube used to remove the urine from the body. One other thing I want you to notice while you're looking at this illustration is that the kidneys are connected directly to the aorta. This is the biggest artery in the body. This facilitates the near constant blood flow the kidneys need to do their job. Okay, now we're going to get in a little deeper here. Okay, this stuff is not even covered in your text. But I'd like you to leave here today with a basic understanding of how this whole filtration, making pee operation works. On this slide, you see a structure, and it's known as Bowman's capsule. Don't worry, you're not going to be asked that on the test. This is part of a bigger structure called the nephron, and it's where filtration actually occurs. And here's how it works. A blood vessel brings blood into the nephron, and a branch from that blood vessel, called an afferent arteriole, branches off and enters Bowman's capsule. From it, smaller branches are formed, creating a capillary bed. Then all those capillaries rejoin to form the efferent arteriole that exits the capsule. Now note, these are arterioles. That means there's quite a bit of blood pressure in these vessels, and it's that pressure that forces the waste products out of the capillary bed and into that surrounding capsule. Let's call the waste bad stuff. That's a great idea, but there is a little bit of a problem here. That pressure also forces out some good stuff. Good stuff includes things like water, electrolytes, sugar, and other stuff we'd rather hold on to. So what we need is a mechanism to recapture that good stuff, and fortunately we have one. And we'll take a look at that on our next slide. Okay, now let me orient you to this bigger picture. We see the capsule where filtration occurs here, right? The filtrate, that's what we call the mixture of good stuff and bad stuff that has come out of the blood vessels and entered the capsule. Well, that stuff, that filtrate, starts to flow through these tubules that are kind of mixed up. Then they go down and they make this loop. Then they're mixed up again. And finally they empty over here into this collecting tubule. Now notice that that efferent arteriole starts to branch out and it surrounds all of those little tubules I just talked about. Since the tubules and the blood vessels are in such close proximity, systems are able to pump the good stuff out of the filtrate and back into the blood vessels so our bodies can reuse it. The stuff that finally makes it all the way to the collecting tubes is what we call urine. And it flows out into larger and larger tubes that eventually meet at the ureter, which transports that urine to the bladder for storage until it can be eliminated. One final comment on this section. These nephrons are microscopic. We have millions of them between our two kidneys. We actually have way more than we need. You can actually lose about 65% of your functioning neurons before you have any type of a serious medical problem. That's why one person can donate a kidney to someone else and still live a normal life. Pretty cool, huh? Well, that's it. That concludes our lesson on the renal system. I hope you have a little more respect for your kidneys and how important they are. And if this doesn't convince you, wait until you transport one of the many renal failure patients out there to their dialysis appointment. You're going to see just how fragile these people are and how adversely their kidney disease impacts their entire quality of life. Okay, catch you later.